We honor to have Mr. Murali Shankar Gopalakrishnan, Senior Vice President, Solutions and Product Engineering Fluentgrid Limited. Mr. Murali Shankar represents Fluentgrid in a capacity of Senior Vice President for Solutions and Product Engineering. He brings in 20 years of experience in telecommunication and utilities industry. He has been pioneer of the R&D activities in the building the CIS and AMI platform for Fluentgrid. Apart from providing the directions in the executing of AMI project for multiple Indian electrical distribution utilities. Mr. Gopalakrishnan will present a talk on connected device and Internet of Things.
Fluentgrid is deeply imbibed into the enabling of IoT devices across different verticals. And today we would be focusing on the electricity side of things and how the devices enable the gathering of the various data and how it's transforming the business for the electrical utilities. First, I think the smart metering, which is being strongly driven by the RDSS scheme in India. The key driving force behind rollout of multiple AMI installations across multiple utilities around in India and also in the globe as well. However, in India, there is a lot of impetus today as we speak, and this initiative started in India somewhere around a decade back with something called an NSGM mission, where there were pilots made, and from then on, we are seeing some active rollouts that are happening, and have been seeing lots of smart meters getting added in the ecosystem. So these smart meters act as devices which enable the data acquisition by the meter read data acquisition system in the background. And this acquisition happens through varied means. Could be a RF-based communication, or it could be a LoRaWAN-based communication, or it could be a direct cellular-based communication over 4G or NB-IoT. We'll delve in a little bit more detail soon enough. The EV charging is one of the other primary use cases that drive the IoT as a platform within the electrical utility, where the charging stations needs multiple sensors within it to measure various parameters and govern various aspects of the EV charging that are very important to ensure a seamless delivery of the energy to the consumers, which also includes the EVs as far as EV charging is concerned. We'll soon get into a little bit more details. The solar farms, as a lot of emphasis has been given on the renewable energy, with a lot of thrust on going green and reducing the fossil fuels. The number of solar plants that has been coming up in the ecosystem is significant, and today there is a lot of sensors surrounding the power plant or the solar power plant data acquisition and measuring the energy that is getting pumped as export energy into the substations, which is something that's important to measure. And the substation monitoring itself, which today is predominantly driven through a SCADA system, and will continue to be. However, the important part of it is there are various sensors and devices within the substation that also forms a larger part of monitoring and governing the assets within the substation. And it's one important aspect that use case that electrical utility considers when governing the distribution or the transmission network of the electricity. And finally, the home area network, which is something that's more driven by the Zigbee kind of protocols, which enables the devices within the respective homes, or probably even the street lights to be able to participate in the larger grid by itself. However, that's still way to go before we mature up on the home area network within our country. Smart metering is predominantly driven by the IEC 62055 specification when integrating with the meters, and within the India, the BIS standards that govern it, the 16999 standards and 15959 standards, which are a wrapper over the IEC 62056 specifications from the data acquisition level, and the meter read dissipation governed by the 61968 specifications, which essentially means there are specifications that govern acquisition of the data from these devices, and the primary objective of this, the primary driving force, as already stated, is RDSS scheme. And the objective of doing this or enabling this devices, gathering data from these devices as a part of the RDSS scheme, is improving the collection efficiency, which essentially means all those consumers can be prepaid, and we would be able to do a remote connect disconnect, and hence improved collection efficiency, which is in place in many utilities now, and being done in a very phased manner across multiple utilities. Reducing pilferages, which is something leveraging on the data that is produced by these devices, ability to analyze the consumption pattern and identifying the possible pilferages, and doing an AI/ML based approach to reducing these pilferages is one of those objectives, and improving the reliability index. So the moment we are able to measure, let's say in India, at least we are talking about a 15-minute measurement precision. So we would be able to measure the outages in the precision of 15 minutes. That would billing based on the reliability indices, measurement of the various parameters surrounding the reliability index, and passing on the credits or penalties, which improves the customer satisfaction in the end, and ultimately increases the consumer transparency in terms of the consumption data available straight away on his mobile on a near real-time basis on the different appliances that he is using. The EV charging is driven by the IEC 61851 specification between the device, which is the electric vehicle in this case, and the charging station itself, or the supply equipment by itself, and at 61850, which is typically driving the data exchange between the supply equipment and the rest of the applications on the ecosystem, which could be the mobile app and the enterprise systems, the backend systems for governing multiple parameters, which include the battery management, which is one of the critical factors that govern the charging system, supply system itself, and energy demand governance in terms of ensuring that the peak demand and off-peak demand are managed well to ensure reliable supply for all consumers, and ensuring that this, what that means is, if in certain periods of time, if there's a higher demand in an industrial area, probably this charging station should be shut down in that particular area and should be real-time available on the mobile app. So the EVs can then get redirected to the corresponding nearest available charging station. So various such kind of use cases that is available and shall be built eventually as more and more charging stations come in the ecosystem, and more EVs come into the ecosystem. And then, as I said, the availability tracking of the EVs itself is something drives the IoT as a phenomena within the electricity distribution. And solar farms done by standard protocols, the Modbus protocol, and again in the IEC 61850 and the Smart Energy Profile 2.0, which enables gathering of the information from the different IEDs and sensors within the substation, which essentially means the solar plant could be running within the substation itself, leveraging on the sensor data for monitoring the various plant sensor readings, and this solar plants or any renewable energy plant for that matter would export the energy into the grid entry point on the power transformer, and there can be net meters, the ABT net meters that could be or would be measuring the injection of the energy through the solar farms, which would enable a better governance of the electricity. And the substation monitoring, which is again driven by 61850 specification, which as a generic object model, which represents the information from each of the sensors and the IEDs, leveraging on the ICCP protocol, which is a typical SCADA protocol. Again, from a data model, still is driven by the Goose information model. Within the substation, there are various assets, the power transformer, the feeders, the auxiliary powers, and the capacitor bank monitoring, and also the automated demand management, as and when there are some discrepancies in the sensor information, the breakers, the relays, relay panels, any discrepancies, then be able to initiate a shutdown on the appropriate assets. Is something important aspect, which is getting governed through the bunch of devices, relay panels within the substation itself. And this information is then sent on a much larger integration and command control center for more efficient monitoring. And finally, the home area network, which is driven by the ZigBee protocol. The IoT cases being, that's quite natural. We use on a daily basis these devices that are the different appliances that are homes or the street lights, which may have their own sensors. And for one of the utilities, for example, we are doing a very nice integrated street light management system, which would enable solar clock based switching on and off of the street lights, and based on the luminescence and based on various other factors of the street lights, be able to predict the failure of the street lights itself, and be able to allow the municipal urban bodies to be able to precisely go to that particular, or govern the field force in going to that particular street light and replace the bulb. And that's the level of use case, or that's the level of benefit that the IoT devices are bringing to the table for the electrical utilities. And more efficient demand response programs, considering that now the customers or the consumers, you and me as citizens, are more empowered to have fine-grained control over the appliances, and we would be able to participate much more efficiently in the green energy initiative, in performing the required load limit during the on-peak or during the peak hours, and participate in the demand response programs that the utilities may launch based on the regulatory aspects that would be launched soon enough, probably. And that would be a much more fine-grained control over the appliances.
Thank you, Mr. Gopal Krishnan, sir, for sharing your views on connected device and the Internet of Things.